is our today's topic. What is our topic is case study on need for second law of thermodynamics. So in the previous classes and in the previous lecture series, we have discussed about the first law of thermodynamics. Okay. Can anyone tell me what is first law of thermodynamics? What first law of thermodynamics is? It deals with internal energy. Okay. Very good. Anything what you know about the first law? It deals with internal energy. Okay.
Q is equal to dU plus work done.
Q is equal to dU plus work done. So these we have stated. We know that what is first law is Q is equal to dU plus W. This is the first law of thermodynamics. Okay. What first law tells is whenever a heat is supplied to a system or some energy is supplied to a system, it is equal to the work done and the internal energy. This is the first law of thermodynamics. But it obeys the law of conservation energy. What law of conservation energy tells is energy is supplied to a system is equal to energy absorbed by the system. So the first law deals with this energy. Okay. But when you are approaching this case to a design thinking approach, okay, what is the first stage in design thinking? Can anyone tell? Empathy. So the first stage is empathy. Okay. So you told that the design thinking approach, the first stage is empathy. Okay. Now let us see what is the empathy in the first law of thermodynamics. Okay. So for this we will have a small example. Okay, a real time example. Let us have a cup of coffee like this. We are having a hot coffee. Okay. So initially when a hot cup of coffee is kept here, what happens is the heat from this coffee will go to the surroundings. Okay, will go to the surroundings. So after a while what happens is the heat lost from the cup of coffee is equal to the heat gained by the surroundings. So this obeys the first law of thermodynamics and the law of conservation energy. So this we have studied. But here is a small empathy part. We are going to see an empathy part. Okay. Now is it possible to reverse this? What the heat goes to the surroundings, will it possibly come back and it is possible, anything is possible like this? No. So this is the empathy part here, the first law of thermodynamics. So here we don't know what happens when the direction is the process reversed or it is happens. We have any idea in this first law of thermodynamics. If you take another example, okay, if you have a closed insulated chamber like this, okay, and there is a paddle wheel, okay, which is supported by a load, so this due to drop in this load, what happens is this paddle wheel rotates. So some heat energy is absorbed by the fluid inside. Okay. So the heat energy absorbed or released from the paddle wheel is equal to the heat absorbed by the water or some fluid. Is it possible to reverse this process? So here, coming to this empathy, what is the empathy in the first law of thermodynamics is, it gives a clear-cut idea that energy lost or energy gained is equal, but it does not specify the direction. Okay. So we need a set of rules or set of things to guide the direction and as well as the energy. So this is given by the second law of thermodynamics. Can you understand? This is given by the second law of thermodynamics. And again we are going to deal with the entropy. Now there is two laws in the second law of thermodynamics. One is Kelvin-Planck statement, another one is the Clausius statement. So these Kelvin-Planck statement and Clausius statements gives a clear-cut idea about the second law of thermodynamics. Okay. So now let us see how this is made is possible. Okay. For this we have to know three things. Okay. One is a source, another one is a sink, and third one is a heat engine. Okay. Three things you can take it. Okay. What is the source is called as an, it is called as an thermal reservoir. It is called as a thermal reservoir. Okay. What is the purpose of the source is, it continuously supplies heat to an system. That is called as an source. So normally it supplies heat. So this is taken as hot body. This is taken as hot body. And the temperature of that hot body is given as heat. Okay. So what is sink is? Sink is continuously absorbs the heat energy. Okay. Continuously absorbs the heat energy. That is called as a sink. Okay. Now, when heat is supplied to a system, it goes from a hot body to a cold body. So normally sink is a cold body. Normally sink is a cold. Now, what is a heat engine? So a heat engine is a device where when heat is supplied to a system, it is converted into work. What is heat engine? The heat is supplied to a system, then it is converted into work. So it gains its internal energy and some converts into work. So these three are very important. Okay, source, sink, and then heat engine. Okay. Now, if there is an engine, how to find out the efficiency